Hello everyone. Today in this presentation we are going to talk about linear visualization on networks. First of all, we will talk about what is the motivation behind linear visualization. In general, large networks are characterized by communities. Communities are nothing but subset of nodes that are more connected within than the rest of the networks. So whenever a user is analyzing large network, user is generally interested in important communities. For example, the user might be interested in large communities or more dense communities or the community that is highly interconnected to other communities. Such analysis find application in wide variety of applications like in social networks, understanding organizational structures and biological structures. Next, we talk about what all are the contributions of linear visualization. Linear visualization is a scalable visualization that can visualize large graphs. Next, linear visualization provides a framework for ordering the communities so that user can focus on important communities in the networks. Next, once the user identify the important communities, the user can also visualize the node centrality from linear visualization. Next, these are the various steps that are followed to develop linear visualization. First of all, we take network data as input and apply community detection algorithm like Loewen algorithm to identify communities or subset of nodes that are more connected within than the rest of the network. Once we have the communities, we order the nodes in each communities based on centrality. For example, degree centrality, betweenness centrality, eigencentrality, and closeness centrality. The nodes are ordered in descending order based on any of these centrality value and are arranged in a linear wraparound layout such that the position of the node along the linear wraparound layout represents the node centrality. Next, we also give user the capability to order the communities. The user can order the community, order or rank the communities based on different community attributes like size of the community, edge density of the community, and number of community connections. So once we have the ordering in the community, we can place these communities or linear wraparound layouts one after the another along vertical axis. This type of arrangement helps a user to compare different communities and to identify important communities. Next, we demonstrate the dashboard of linear visualization. The linear visualization, this linear visualization is developed on Last.fm dataset that contains 7,600 nodes and 27,000 edges. In this visualization, we see that nodes are colored based on edge density that can be seen from the side legend, and we use the following color coding. For example, the red color represent high values, orange color represent medium value, and blue color shows the low values. Then if there are outliers or very high values, that are represented by black color. So whenever a user hovers on a node, all the node connection or all the adjacent node to that particular node are highlighted by changing the size of the node, and this is represented by dark blue color. Also in this visualization, we have community nodes that are integrated along the vertical axis. The vertical axis has the community IDs and the community nodes. Whenever a user hover on a community node, we can see that all the communities to which this particular community is connected gets highlighted. So this can be seen in linear visualization as opacity of those community is different from those communities that are not connected to community number 9. Also we have this another visualization, that is interlinked chart or interlinked node link visualization of the coarse graph of the communities that represents the edges of community number 9, or how community number 9 is connected to another communities. Also, there is this metadata that represents that this is community number 9, what are the number of nodes present in this community, what is the edge density, and to which all communities community number 9 is connected, and how many are the number of connection between those two communities. Now next we have this sidebar. In the sidebar, we have various options like ranking the nodes. The user can rank the nodes based on different centrality measures like degree, closeness, betweenness, and eigencentrality. Also, user can rank the communities based on size or based on density, based on community connections. For example, community number 3 is connected to all the other communities we can see in this visualization, and if we hover on community number 9, it is connected only to community number 3, 5, and 8. Next, this visualization also provide user the capability to change the color coding. The user can color code either based on edge density or based on centrality values. For example, if we click degree, the nodes are already ordered based on degree, and if we color code these nodes based on degree, then we can see the distribution of the degree centrality across and within the communities. Now, let's talk about how we will interpret this linear visualization. So first of all, by default, we can see that communities are ordered based on community IDs. So whenever a user see this visualization, user can easily interpret the number of nodes present, number of communities present in the network. Also, the user can identify the communities very well from this legend. Then the user can also interpret the size of the community through the length of this linearly wrapped layout. In order to facilitate the comprehension of size, user can rank the communities based on size. So now the user can easily interpret that community number 1 is largest in size, followed by community number 8, 6, and so on. Next, in order to interpret the edge density, the user can either use the color coding. As we know that community number 9 has the highest edge density. Also, the user can order the communities based on edge density, which shows that community number 9 has highest edge density, then 7, 2, and so on. So this particular ranking, it helps user to identify the ranking of the communities based on density. For example, the user can easily answer the question like, can you identify the 4th densest community? So user can easily answer these questions using this type of visualization. So once we understand the edge density, we have already seen that on hovering on a particular node, the user can see the node connections by the highlight features. Then a user can also comprehend the community connections. Also, the user can see the through the length of the linear layout, user can comprehend the size of the communities. User can also comprehend the node centrality as well as the ranking of the communities. So it can be said that using this visualization, a user can comprehend a lot of properties. Thank you.